Starting with the name of Almighty Allah. In this video, we will learn that how we can draw the Mohr circle for determination of shear strength parameters from the Mohr circle. So, in the previous videos, we just learned that how we can draw a generalized Mohr circle for the stress determination, and we also learned how we can perform the calculation for triaxial test. But in this video we will learn that how we can draw a semi-circle or a Mohr circle for triaxial test. Either it can be UU test, CU or CD test. So before starting the videos, those who haven't subscribed the channel can subscribe to watch more such useful videos, and you can also join our Facebook page for more updates. So we have taken the data from this test, and we need to draw the Mohr circle like these. So we have taken the data from these results. These are CD test. So we have the axial stress or deviatoric stress 79.841 for first trial, and cell pressure is 20. So we can add 20 plus 79 to get sigma 1. So this is the data of trial 1. We have the data of trial 2, and similarly we have the data for trial 3. So we have gathered we have extracted the data from these tests, and we have this information over here. We have sigma 1, that is axial stress 100, that is basically 79.8 plus 20, that was cell pressure. So we have 100, round of value 100. Now we need to find out R, that is sigma 1 minus sigma 3 divided by 2. So we have this value 100 minus this divided by 2. Similarly, we need to find out sigma average to draw the Mohr circle. We have sigma 1 value plus sigma 3 value divided by 2, and tau xy in our case is 0 for triaxial test. For trial 2, we'll repeat the same procedure. Divided by 2 is equals to, we have this value divided by 2, and 0 for the tau value, this case. Now again the same process will be repeated. Now we have performed the basic calculations. Now we need to draw the Mohr circle. For Mohr circle, we need the angle, because we want to draw half circle. In half circle there is total angle of 180 degrees, so we need the points against each degree of angle. So we will draw the points or stresses against each degree of angle. So 0, 1, 2, and the same sequence will be repeated till 180 degree. So we can select these cells and can drag this sequence to all the cells. So you can see we have the value 180 degree. Now we need to transform the stresses for every angle. So we have normal stress. The normal stress formula is given over here: sigma 1 plus sigma 3 divided by 2 plus sigma 1 minus sigma 3 divided by 2 cos 2 theta, and tau xy in our case for triaxial test is 0. So we can further simplify this formula as sigma average plus r cos 2 theta, sigma average plus r cos 2 theta. So we can apply the formula sigma average, this plus R value here, multiply by cos. So as in Excel we need As in Excel, we need to define the value in radians. So we need to convert the value of degree into radians. To convert the value of degree into radians, we need to multiply it by 0.01745. So we will multiply it by 0.01745 multiply by 0 degree angle of degrees. But we need to fix the values because R and sigma average value will remain constant throughout the cells against each degree of angle. So we need to put the sign of dollar, shift 4. So this is how we have transformed the value of sigma n against 0 degree. Now we will apply this formula to all the cells against each degree of angle. So we have the normal stress against each angle. We can reduce the decimals like this. Now we need to apply the formula tau, our shear stress that has sigma 1 minus sigma 3 divided by 2 into sine 2 theta, and this function is 0 basically. So we have R value multiply by sine 0 multiply by 0.01745, but we need to fix the value of the 18. Shift dollar. Now we can drag this formula and we can reduce the decimals from here. So now the next step is the angle. Same process will be repeated. We can drag this sequence till 180 degrees. Now we need to apply the formula for trial 2 and trial 3 for sigma n. Plus R multiply by cos 0.01745 multiply by this bracket close. We need to apply the sign of dollar. Okay, so we will drag this formula to apply it to all the cells. We can reduce the decimals. Now to find out the tau value, or multiply by sine 0 multiply by 0.01745. We need to fix this value, put the sign dollar. Okay, now we will drag this formula to all the cells. The same process will be repeated. I will just copy this cell, Control C here. Now sigma n, the same process, sigma average plus R multiply by cos 0.01745 multiply by angle degrees. We need to fix these cells. Shift dollar, sign of dollar here. Okay. We will now drag this formula to all the cells. Now R value multiplied by 0.01745 multiply by this, and we need to put the sign of dollar over here. Click OK, and we will drag this formula. Now we can draw the Mohr circle. So we will get to the insert, we will select this, and now right click, select data, add trial 1, and along x-axis we'll put these normal stresses. And along y-axis we'll put the shear stresses. This one. Till that. So you can see the first Mohr circle for the trial 1 has been drawn. Now we need to add for the trial 2, trial 02, the same procedure will be repeated for the trial 2 and 3. Now the data for the trial 2 has been drawn. Now we'll have to add another trial, that is trial 3, and along the x-axis the same procedure will be repeated, and we'll select this column for trial 3. We can name it as Mohr circle for triaxial test. It can be UU, CU, CD. No need to write it. You can. Okay. Trial 3. Okay, now the Mohr circle for all the 3 trials have been drawn. Now the next question is how to determine the shear strength parameter, cohesion and angle of internal friction. So remember, this is a total stress the Mohr circle has been drawn against the total stress. You can draw the Mohr circle for the effective stresses as well. So now to roughly guess the idea how much the cohesion is. Cohesion is basically the y-intercept. So I will go to insert and shapes. If you want to do it manually, you can do simply by selecting line. I just need to have a rough idea that how much the cohesion is for our case. So what can be the perfect line? So you can see here it is approximately 24 and it is 55 here and 100. So now I will delete this line because I want an automatic the Mohr circle that gives us the automatic values. So now to draw the line, we have the coordinates. Let's say it was 24 here, so 0, and the next coordinate will be 24, and the next coordinate was 100 and 55 above. So now see how I draw a line. To automate the process, select data, add for the line failure envelope. To draw the failure envelope, basically along x-axis I will be selecting these two coordinates, and for y-axis I will be selecting these two coordinates, and you can see the line has been drawn. Now why I have automated the process? Okay, if you get the value roughly, if you get like it's 25, you can change this. You can see the line has been changed. You can use some trial and error method like 24. This value can be different by your approximation. Like if you choose it 60, then the line will be like that, but you need to adjust it like I have adjusted it. So this is a proper circle now. Now the next question, how we can determine angle of internal friction. Now we have the value of cohesion, but how we can determine the angle of internal friction? So just like this line, go here, and now you need to define the trend line. Yes, so it is a linear basically. So we want to apply a linear trend to the failure envelope line. So okay, now you need to right click over here and display the equation over the chart. Now this is the equation of this line. As we know that slope of this line is basically the angle of internal friction. So we have 0.31 is the slope, 24 is the cohesion. Now we can see the cohesion value is 24 kPa, and angle of internal friction is, the slope is 0.31, so we need to apply the tan inverse. A tan is the command, A tan. The number is 0.31, but we need to convert the value in degrees, but Excel takes the value in radian, so we need to multiply it by 57.1. that is basically 180 divided by pi. So 57.29. Okay, so 17 degree is the angle of internal friction. We can say friction angle. So this is how we can find out the shear strength parameters by drawing Mohr circle. I hope you like the video. If you like the video, don't forget to subscribe and share. And Allah Hafiz.